Hi everybody, and welcome to the Azure Advent Calendar. My name is Simon Waight, and this 1st of December 2019 edition, I'm going to be covering Azure Logic Apps, which are a great serverless no-code way of building solutions inside of the Azure platform. This is only one of a series of videos in the Advent Calendar, which you can find out more about at azureadventcalendar.com, which is being produced by the MVP community. Many thanks to the community for allowing me to contribute to a video for the series. Make sure you check out all the other great ones, and a special hello to all the people in Bristol who I said I'd say hello to. Alright, let's get started.
Hope everyone is nice and toasty after that sunny intro. Now on to the core of this session. We're going to take a short journey through covering Azure Logic Apps, something that thankfully doesn't require me to use my limited graphical design skills. Also, make sure to check out the other Azure Advent Calendar session from Henry Bean, who will cover how to do continuous integration and deployment with Logic Apps, along with how you can build your own custom connectors. This session is really designed as an overview of Azure Logic Apps. So first of all, we'll look at what are they. Then we'll understand what the inbuilt connectors and actions are that you have available to you as a developer. We'll see how you can do development for Azure Logic Apps. And then we'll close out with some basic Logic Apps best practices, followed by a demo. Azure Logic Apps are a simple to use yet powerful way to develop integration solutions without the need to write code or worry about setting up execution environments. When you develop a Logic App, you use a graphical designer to build workflows which are persisted to a JSON formatted file, which can then be stored in source control, manipulated directly or via a designer. When running Azure Logic Apps, use the same orchestrator as the Azure Resource Manager service in Azure, which is a highly reliable and scalable service which removes the need for developers or operators to worry about reliability of the service. If you utilize integration service environments, or ISEs, you can have individual Logic Apps run for up to 365 days. The standard Azure Logic App environments, which you would typically use in the portal, can have individual workflows that run for up to 90 days. A real time-saving feature of developing with Logic Apps is the hundreds of pre-built connectors and associated actions which make integration into both Microsoft and third-party systems as simple as setting some parameters for a connection. If you have worked with Power Automate, or formerly known as Microsoft Flow, then Logic Apps will seem familiar, and the connector ecosystem is shared between the Power Platform and Azure Logic Apps. People coming from enterprise integration that may need to do EDI-style integration can achieve this capability using the Enterprise Integration Pack, or EIP, which can be installed by setting up an integration account. You aren't limited to integration with Azure hosted or SaaS services. There is the ability to connect on-premises or hybrid cloud systems by way of a dedicated data gateway, which you can install and run on infrastructure running outside of Azure. Logic Apps are also used in many places inside of Azure to provide easy extensibility. Azure Sentinel runbooks are Logic Apps, and Azure Monitor alerts can invoke Logic Apps. The easiest way to wrap your head around Logic Apps and the core ideas is to see how they look. On this screen we have a simple view of a Logic App during build. We have a trigger, in this case monitoring an RSS feed, for news items. Note that we don't need to build anything into our solution to track state of the upstream feed. That's done for us in this case by the Logic App itself. The trigger then calls a send email action we've added to the Logic App. This particular action uses Office 365 Outlook in order to send an email originating from Sophia Owen's mail address, and will have a dynamic subject line based on the title of the new RSS feed item, creating this particular triggered workflow. We have achieved this setup without needing to do more than configure the trigger's properties to read from the RSS feed and to then perform an OAuth grant for the Office 365 connector so it can connect to Sophia's mailbox and send on her behalf. This simple screenshot doesn't show the control actions such as the if conditions or the for each or scopes, which can be used to control error handling. We'll talk a little bit more about those later on. Most developers struggle moving to Logic Apps because they just want to write code sometimes. Expressions, which are shown in the right hand of the screenshot above, provide you with simple methods which allow you to manipulate content in the Logic App. And there are also actions which allow you to write small amounts of JavaScript code in place of graphical designers. Additionally, you can always branch out and call Azure functions and other logic if really needed. You can go ahead and read more on this demonstration at the source link under the image in this slide. When you create an Azure Logic App inside of Azure, it runs in a multi-tenant environment that would be familiar to anyone hosting in a public cloud environment. These standard Logic Apps are very powerful, but there are certain capabilities or integrations that your organization wishes to use, which is where integration service environments or ISEs come into play. If you are unsure how much usage you will make of Logic Apps or certain paid connectors, then it may make sense to start with a standard Logic App and then move to an integrated service environment in the longer term. High compliance industries that must have demonstrable separation from other tenants can utilize ISEs to achieve this, along with adding the ability to connect directly from Azure Virtual Networks and access resources hosted on Azure infrastructure or on-premises via a data gateway. ISEs also introduced a fixed cost billing model which includes certain services you would pay additional for as part of the standard Logic App service. From a cost management perspective, it may make sense, depending on your integrations and their connectors, to move to using an integration service environment over standard Logic Apps over time. The 365-day duration is available when you use ISEs. Standard Logic Apps can only run for up to 90 days. As I mentioned previously, the power of Logic Apps is the sheer volume of connectors available to developers to start working with right away. These are organized into groups to make it easier to understand when to use a particular connector. Built-in triggers and actions provide you with basic capabilities for integration. The scheduled trigger lives here. It's the trigger that allows you to run things hourly, daily, weekly, or at certain dates. Simple HTTP integration is also included under this category, along with integration into other Azure services such as functions, API management, and app service. The standard flow control actions such as if conditions, for each, and switch fit in here as well. Finally, for built-ins, we have basic data operations such as parsing JSON, variable management, and datetime object manipulation. Next, we have managed API connectors that provide Microsoft and third-party API integration endpoints. SQL Server, Office 365, and Dynamics are some of the Microsoft-centric services bundled here, with Twitter and Salesforce being the two non-Microsoft services that have connectors falling under the managed category. On-premises connectors require the use of a data gateway to provide a secured transport back to your on-prem environment. Connectors here aren't necessarily limited to on-premises use, but are often present in those environments. A sample of connectors from this category includes services such as BizTalk Server, IBM DB2, MySQL, PostgreSQL, and Oracle. Integration account connectors are only available when you create an integration account. This account construct unlocks actions for processing EDI messages in formats such as AS2, Edifact, XML, and X12. The final category of connectors is Enterprise, which includes the IBM 3270 green screen integration capability, IBM Q series messaging, and SAP integration. If you still find a gap in the existing set of connectors, you can always build your own. Henry Bean's session for the Azure Advent Calendar will cover how you can build custom connectors, so make sure you check that out. Find more information on connectors at the two links shown on this screen. There are a few options when it comes to how you develop Logic Apps. The quickest way to get going with Logic Apps is to use the Azure Portal to create and configure a Logic App. The Logic App Designer is a web-based designer, so your best experience for it today is in a browser. You can export your Logic App once you've finished building it, parameterize the resulting JSON template, and then use a CI/CD setup to deploy it into multiple Azure tenants. If you're already a Visual Studio user, then you can install the Logic Apps extension and use Visual Studio to develop Logic Apps locally. It's worth making sure that you use Azure Key Vault to manage your secrets that you may wish to deploy when you deploy your Logic App into Azure. This way, the secrets are not embedded in the JSON and will not appear in plain text in any telemetry emitted by the Azure Orchestrator at runtime. Finally, we have Visual Studio Code, which right now provides just basic editing features for Logic Apps that gives you an IntelliSense-aware editing of the JSON code behind that makes up a Logic App. You can view the graphical representation of the Logic App, but it isn't currently editable. Hopefully we'll see this feature in a future update. Let's wrap up with a few Azure Logic Apps best practices. Given how easy it is to start building Logic Apps, it can also be very easy to build complex workflows that are closely tied to the API model response from your initial trigger. Once Logic Apps are built, it is almost impossible to easily change earlier steps in a workflow of which the trigger is actually the first. It's good practice to separate out the initial trigger, say an RSS feed item like we saw earlier, from the remaining business logic. The way to achieve this is to use a second logic app that you call from the initial logic app. Rather than simply pass on the raw API model from the first logic app's trigger, you can convert the API model into an internal representation that makes sense for your use case, and then pass this internal representation onto the second logic app. This way, should you ever need to change the trigger, it would be much easier to do it in a single than it would be in a single tightly coupled logic app. The next item is to use scoping in your logic apps. Again, it's easier to put a logic app together without this, but if an early stage action in your logic app fails, should it necessarily mean the entire logic app fails? Also, the larger your logic app gets, the harder it may be to visualize. You can use scopes to control both of these challenges in your logic apps. Check out the link for additional information. Associated with scoping is error and exception handling. As a developer, you have a lot of control over what happens when remote APIs return an unexpected response or error, or if there is a bug in your code and the actions logic causes it to throw an error. The default behavior in logic apps is to stop the current processing run on error. Parallel for each loops will continue to execute, but you might have a bunch of weird or unexpected outcomes as a result of the error in one of those runs. Using a scope to manage the code inside of for each, and also utilizing the run after property of an action, gives you control over what should happen in the event of an error. I recommend having a read of the official documentation for detailed guidance and advice. Finally, but by no means unimportantly, we have secrets and identity management. When managing secrets in Azure, the best place to store these items is in Azure Key Vault. Unsurprisingly, logic apps have a rich set of Key Vault connectors which allow you to read secrets from Key Vault at runtime and then use them as required in other actions. When you deploy Azure Logic Apps using the Visual Studio tooling, you can also utilize Key Vault to store secrets such that they do not appear in your JSON markup, which you commit to source control. When you create a connection to third-party APIs, those details are not held in plain text either, so you're not at risk of leaking those credentials when exporting Logic Apps. Additionally, Logic Apps can utilize Azure's Managed Service Identity, or MSI, delegation approach for authorization against other Azure services. This is a great way to enable access to other services without needing to generate and manage any form of credential that has potential to be leaked. Additionally, when you delete the Logic app, the MSI created for it is also deleted, removing one management overhead and potentially a longer-term security issue. Okay folks, let's get into our demo. Today we're going to build a Logic app that uses GitHub as its trigger source, so when a new issue is opened and assigned to me, I want to post a message into a Slack channel and also send an email that contains a link out to that particular issue. So I'm here in the Azure Portal, and what I'm going to do first is I'm going to add a new Logic app. Our empty Logic app's been created, and when we click on it for the first time, we get taken to the designer view. Now we have a bunch of pre-built Logic apps templates that we could use here if we wanted to, but what I'm going to do is I'm going to actually start with a blank Logic app. Okay, so now we have our empty Logic app ready to rock and roll. We're going to add our GitHub trigger for when a new issue is open and assigned to me. I'm not having to connect and authorize this particular trigger because I've done that previously when I was going through making sure this demo is going to function. So it's connected under the context of my GitHub user to my organization. I don't need to tell it a repository to look for issues for. I could put a filter in upstream if I wanted to do that, but for now, every minute I'm going to look for when a new issue is open and assigned to me. The next thing we're going to do is we're going to initialize a variable, and initialize a variable that will hold the message body. And the message body is going to consist of the content we actually want to post to the user channels that we want to share this information on. So let's just put in some content for this. So I can come in and choose the user's login, so the person who actually created the issue. I can put in the body of the particular issue, so I've got the content of the body. And then I have finally a link out to the issue. Now this final one here is a bit tricky because the GitHub trigger doesn't expose the particular property we want. It's there in the result, but it's not represented in one of these particular field types here. So what we can actually do is, because the content's there and because I've gone off and identified it previously, I can actually use an expression to get to this. There's nothing stops you from being able to go and look at this as well, so you can execute the Logic app and then have a look at the outputs, which we'll have a look at in a minute. Expressions are very powerful and you can do lots of different things with them. As a programmer, this is probably where you'll spend some time doing some content manipulation before you use it inside of your actions or your outbound connections. So I already know that the particular property in the response object I'm looking for is called HTML_URL. Trigger body expression gives me access to the outputs from the trigger, and I know that the array element I want is called HTML_URL. So I'm going to save that. That'll be replaced when we come back to this later. We'll see that that trigger body function call is replaced by a property because the environment for Logic Apps is smart enough to understand that. So now we have our variable set up. The next thing I want to do is I don't want to treat all of my issues with the same priority. So what I'm going to do is I'm going to take if the title, so that's basically the subject line, contains the word urgent. I'm going to change this to an or. I'm going to add another one. And the other thing I want to do is if the body contains the word urgent. So if either of those properties are true, what I'm going to do is I'm going to choose my Slack connector. I'm going to post a message. Now I need to sign into my Slack organization. So again, I've done that previously. So when I hit this button, we'll get our button show. And what will happen is after it's done the OAuth into my Slack organization, that window will close. Normally I'd be asked to grant access, but I've done that previously. Oh, here we are. Actually, I'm going to be asked to do that again. So let's allow that. Okay, so it'll give me access to all of the channels that I have and then the message text. So what I'm actually going to do here is, because this is the urgent stream, I'm going to do something a little bit different. I'm going to insert some emojis. Because everybody loves bang emojis. And then the next thing I'm going to do is I'm actually going to use our message body variable from before. So that will be posted into the demos channel for us if the title or the body of the new issue contains the word urgent. So we want to do the same in the event that it's a non-urgent message. So we'll still post it into the same channel, but all we're going to do now is we'll put the message body. So that's already fairly powerful, but let's not limit ourselves to just posting to one channel. Let's send an email as well. So what I'm going to do is I'm going to use the Office 365 Outlook connector. So this is the version 2 connector for this particular service. I could use, say, the G Suite Gmail connector as well if I wanted to do that. And what I'm going to do is I'm going to send an email. And again, I'll need to authorize the connection, so it'll connect to my Office 365 tenant in my user context. So I'm going to sign in for that. And once I've created these connections, the great thing is that I don't need to do them for every single time I want to connect into that Office 365 tenant. It's done for me once as the connection, and then I can reuse that connection across all of the connectors that pertain to that particular environment. So I'm going to Hardcode, who I want to send this to. I'm going to send it to my Gmail account, and I'm going to put this is a urgent issue on GitHub, and I'm going to put my message body in here. And the next thing I'm going to do is I'm also going to set the importance flag on this, because I want it to be urgent when it gets sent. So we add that parameter, and then we can set it to high importance. And then, as you can guess, on the other branch, what we're going to do is we're going to send the email. I'm going to send it to the same address. Now I could have pulled this address from a variable potentially, so I only had to set it once. And I can put non-urgent issue. Put the message body in here. Okay, so that's our simple logic app. Let's save that. So nothing's as good as a demo, so let's go over to GitHub, and we'll create a new issue. And we're going to so we need something to trigger this. I need to make sure I assign it to myself. I'm going to submit that. So if we come over into our Slack tenant, so there's our message with the link out to the issue that we can click to open, and we should find that we'll also get that show up in Gmail as well in a moment. And it's marked as important according to Google Magic. So there we have a simple demo that shows you how you can use Logic Apps to send out the same message to multiple channels. The other thing I will quickly show you is once this has run, we'll get the run history. We can see that this one succeeded and it took 968 milliseconds. Now if we open this, we get a nice visual representation of the run, so we can see which branches ran and potentially which branches failed as well. So we can see that we ran down through the urgent message branch. We can also have a look at what the outputs of these particular actions were. So we can show the raw outputs, which basically gives us the JSON, and we can see that the HTML URL that I was using is embedded inside of the message body. So that's how I could go away and dig it out. Initialize variable, we can see that the substitution took place here. So there's my handle, and then this is the original text from the GitHub issue, and then the HTML URL, which takes us directly to the issue. Finally, we can see what was sent to Slack, and we can see potentially the responses. So we can see that the Slack basically converted the emojis into colon-based emojis, and then the send email as well. We can see that the email resulted in a 200 response that actually sent that email fine. So that's a really simple demo to show you how powerful Logic Apps can be. Just a few connections and a little bit of thinking can really get you into a space that you can build powerful integrations fairly easily. I hope you've enjoyed the demo, and just back to the slides to wrap up for today. So that's it, folks, for this session on introducing Azure Logic Apps. Make sure to check out other Azure Advent Calendar sessions, including the one from Henry Bean, who will be covering how to do continuous integration and deployment with Logic Apps, along with how you can build your own custom connectors. There are also a range of other Azure capabilities covered across the sessions, to make sure you visit the Calendar website to see what other great content there is. My name's Simon Waight, and I hope to catch you online or in person at an event. Thanks a lot for your time, and I hope you enjoyed it.